So before we go into the detail on the internal stacks within the digital building platform, it's probably a good time to discuss the reasons why it makes business sense to have this platform in the first place. The real questions should never really be how does it work or even what type of AI or analytics are on offer. It's about delivering answers to the business problems and questions. Essentially, what business advantage does this platform provide, or what business process does this platform make more efficient? In short, if I invest in this technology, what quantifiable returns will I get for the platform implementation in its own right? And that's a fairly fundamental question, and that's true of any technology. So, to get a handle on this, it can be broken down into two main elements: direct business drivers and technical challenges. And they're somewhat interrelated because the technical challenges will solve a problem at some point, but it may be indirectly. There is a lot of data generated from buildings, and the expense of storing and managing these volumes means it needs to perform. It needs to deliver its own ROI, and that can come in many guises. And some of it will be business specific, some of it will be building specific. I think the unique element on the digital building platform is that it provides the basic baseload of learning behind it. So it will be able to characterize and learn your building no matter what type of business you are or what type of building you have. And it's then how you build on top of that base learned models that you can extract even more value. And in the earlier slides, you saw those other elements of satellite services. And they don't necessarily have to come from future decisions. So some of the key questions and that probably should be answered are, well, as a business driver, what do I need? What are the questions I might have? And some of them will just be pure decision-making questions. So it'll be around space utilization, for example. You might be asking yourself, well, my building is very, very busy right now. Do I need to expand my floor space? Can I downsize my floor space? Do I need to go and build a new building? These are all very, very expensive questions. And they're very hard to answer without metrics, without measured empirical data. So one of the offerings that connects to the digital building platform is a space utilization element. So it's a room booking, parking booking, hot desk booking, and so on element. And that integrates via the API, like all other third-party softwares, into the platform. So we're able to use a lot of the sensors and a lot of the tools and a lot of the inbuilt capability of the building that's already there. And that's done purely to reduce cost. But what we do with that, and a good example there will be, we have an app that you can talk to on your phone, and it will book the room for you. It will change the heating, the set point, the lighting, that kind of thing. But that all comes through the API. It's treated as an external entity. But what's coming back to the decision-making element, you need to be able to say, well, actually, my space is being overused or underused. And to do that, you need metrics on the data itself. So what we have in our room booking element is a recording of when rooms are booked, whether they're used or not, whether people show up or not, whether they've extended their booking, and so on and so forth. So at the end of the month, you can get a report that will tell you, actually, my building is at capacity or it's currently being underutilized. And you can see on the slide right now, there's a very basic element because it's only a demo account that we've used for the video. But you can get an idea of how many no-shows you've had, whether it's not been used, how much time your meetings are in use, and the same is true for parking and rooms and desks and so on. But with that kind of data, you're able to make an informed decision on space utilization, which means you can make the correct business decision further down the line. So one of the questions we get asked quite frequently is, how do I increase my green credentials? How do I lower my CO2 footprint? And that's really about energy efficiency. Now, there is a very tight relationship between energy efficiency, which is generally most easily sought from acting upon your HVAC system, so your chillers, your fans, your air intakes, and so on. but there is a direct relationship between any changes to your air intakes and the air quality within your building. And by air quality, I mean pollutants that you find outside that are generally, particularly in London, already at illegal levels. So you're talking about NO2, nitrogen dioxide, and particulate matter. Now, what we found over the last 4 years of research and measurement in this is that the air quality inside buildings, particularly during office hours, is worse than the already illegal air you find outside. And that's also partly due to traditional energy efficiency methods. So they seem to be aggravating the problem. And because they're not based or taking into account a holistic view of the building, and are not taking into account the air quality outside as it comes in. It's deemed fresh, and it just is not. So the two, energy efficiency and air quality, have that direct relationship. But let's come back to the energy efficiency now. Energy efficiency can be quite easily gained as long as you know your building capability and the building physics. So essentially what you do is you take the chaos that's normally in the control system, and traditionally that would be in a dead band, and that is just chaos. That isn't true control. So if you take that dead band and you put AI control on that, you're able to remove the chaos from it, and you're able to say, when you have control of that, you're able to predict where you're going to be in an hour or 2 hours time. So if you are able to predict where you're going to be, you can make sure that you're not breaching any SLAs, for example. So you can say, well, if I turn all of this down to its minimum setting, or I turn it off, I'm only going to drop by 1 degree here. My CO2 will stay well within parameters, and it does, because we've done it. So what you're saying is I can put my building into low power mode for the dirtiest periods in the day in terms of the national grid. So energy coming into your building, it can be thought of in the kind of the green, orange, red zones. Red being super dirty, the grid is under stress. Yellow being, it's getting there. And the green being, we've got plenty of power, plenty of capacity, plenty of renewables on hand. And that's, it's more detailed than that, but that's generally the way you can think of it for this presentation. Now, if you know you've got flexibility because you've learned your dynamics, you can get your building ready to be in a particular condition and then put it into a low power mode. There'll be no noticeable effect from the occupant side or from any other element. This is all happening transparently in the background. And you can just coast through the dirty periods of generation or the most expensive periods of generation, and you can have smaller cost in terms of energy cost directly. Now, you do have to take into account the air quality, and we will do a separate dedicated presentation on AI and air quality. But if you don't take it into account in your energy strategies, then what you'll find is that you're going to make the indoor air problem worse. So if you're pulling in already illegal levels of air and you do it at the wrong times, there is an air chemistry relationship between what's inside and what's outside. And it's possible that you pull in, say, ozone, and you already have a lot of NO inside your building, then those two will mix, they'll react, and you'll get nitrogen dioxide buildup within your building as well. And that's just the chemical elements of it. You've also got to prevent your intakes from pulling in the worst of the pollution outside. And we found that we can only achieve good results using modeled AI control. And there's a few caveats in there where we have other like stochastic approaches and so on to make sure that when the models aren't hitting what they need to hit, that it falls back. But we'll probably do a detailed presentation on that independently. But what we found is that we can drop internal pollution levels by 30%, which is enough, particularly, in London, to drop it by 30% will take you from illegal levels indoors to legal levels, which means that you're no longer putting yourself at a risk. It's a business risk. If you have poisonous air in your building and you don't get rid of it, then it's a business risk to your building, and of course it's got a health risk to your occupants. And that's very well, the health risks are very well documented by a publication from the Royal College of Physicians. And if you look at the slide now, you'll see the lower graphic, which is where that graphic comes from, is a publication called Every Breath We Take, the Lifelong Impact of Air Pollution. And it's very well worth a read if you want to see the impact of air pollution on health. But from the upper half of the slide, you can see the impact it has on human health, from dementia, heart disease, stroke, asthma, cancer, obesity. It's affecting not only your health but your productivity as well. So yeah, if you want to deal with that, you can use AI to do that with the with the air quality package we have, which is again a satellite service, but again it has to use the learned building physics from the digital building platform to get the result that you want. Now that we've addressed some of the many business drivers, or the more frequent ones, we can now look at the slightly more indirect benefits. And one of the kind of frequent questions we're asked, and this is usually by third-party BIM suppliers, is how to get real-time data into the BIM model, so that when the end user is looking at their building in 3D or their assets in 3D, they can get an idea of the status of their assets. And that's really just making sure that the data points from the BMS network are transported in a timely manner from that network to the digital building platform, and then out via the API and into the BIM models. And we get that request quite a lot. But as the end user, it's nice to be able to load up your BIM, take a look at what's in there, and see some status information, particularly with respect to alarms and failures. Now, the other one that we come across quite a lot is a more practical setup, and that's to do with meter validation. So quite often, if you have a big block of flats with many meters, or a big building with lots of sub-meters, somebody has to go around and validate those meters. And that can be anywhere from every month to once a year. It depends on the business and the setup. But what we have is a mobile application now that the person going around checking the meters can take with them. They just scan a QR code that identifies the meter, take a photo of the meter, punch in the meter reading, and then send it off to the digital building platform. Now, at the digital building platform layer, we have some vision processing. That vision processing checks the number that the user has inputted as the kilowatt hours or megawatt hours of the meter, and it processes the image of the meter, and it looks for those numbers in the meter and the order that they're in, and just does a secondary machine validation of the user input to try and avoid mistakes. Now, of course, if it flags up a mistake or there is a problem or something went wrong, you don't have to go back to site. You can simply log on to the website, take a look at the images, and then change them from there. It just takes away some of the hassle and some of the difficulty and some of the human error. The other thing we have is dashboarding. That's usually a relatively time-consuming element, but because we have all of the data points in the digital building platform, we have an associated dashboard satellite service where you can just click, within 3 clicks you can have your dashboard more or less set up. So it's essentially drag and drop for dashboarding. So because the digital building platform has the points, they get loaded automatically into our dashboard service, and from there you just select the points you want, the type of chart you want, and you can do it in about 3 clicks. But again, that should be speeding up engineering time and should have a positive cost benefit analysis as a business case.